Hello everyone, my name is Ant. I want to share my thoughts on Hailo with you in this video. 2 years ago I made a video giving an overview of this platform with some basic tests, but now I had a chance to work on several projects using Hailo and I want to dive deeper into my experience. In this video I will discuss the platform strengths and weakness and the main working pipelines. Stay tuned for some valuable insights. Currently, Hailo has 3 different platforms. It's Hailo 8, which is accelerator that you can connect through M2 or PCI Express to your board. It's processor with Hailo 15 coprocessor, which is like fully pre-built system, and it's Hailo 10, which is a bit similar to Hailo 8, but a little bit faster and a little bit more memory and stuff like this. In this video, everything will be primarily about Hailo 8, although it's partially applicable to other platforms, because it's the same framework, same pipelines and stuff like this. Speaking of high-level assessment in terms of software quality, development speed and convenience, Hailo, in my opinion, is worse than NVIDIA TensorRT and Intel OpenVINO inferences. But so far it's superior to other platforms that I have dealt with, like Rockchip, Qualcomm, and a lot of other stuff. So when it comes to work with Hailo, one of the things that you need to consider is what you will be connecting it to. Hailo is not like a single board, it's a coprocessor connected via the PCI Express bus, and its speed depends on the bus width and the speed of your processor. Using Hailo with something like Raspberry Pi 5, for example, might not be the best idea, because Raspberry Pi 5 support only like one line of PCI Express 2. However, utilization, if you want to utilize it with modern processor like Intel i7 or Intel i9, it also may be not the most efficient choice, because nowadays Intel already comes with a robust coprocessor, and probably it's better to utilize first your Intel coprocessor. In my personal opinion, Hailo is best suited for situation when you already have a platform and you hit your limits, and you're looking to enhance its performance just by connecting one M2 additional board. And note that all I mentioned above, it's about Hailo 8, but not about Hailo 15. For Hailo 15 and for Hailo 10, there can be a little bit different logic for the usage. Okay, let's go next. Quantization. It's a topic that's both a strength and the weakness of the Hailo. On the one hand, Hailo's requirement to use quantization, like specifically int 8 or int 4, it can be seen as a limitation, especially when compared to platforms like Intel, NVIDIA and Rockchips, which offer more flexible, like including support for FP16 layers, for example. However, when we look at the bright side, Hailo's strength lies in its robust support for exporting to int 8. Unlike many other platforms, Hailo boasts a variety of methods for exporting models, making it more likely for user to successfully run on their platform. I tested it a lot with different neural networks, and Hailo framework to quantize everything is really great. But you need to quantize, and the quantization, unfortunately, it makes some models impossible to use. This is not a very common situation, but I would, from my experience, estimate from 5 to 10% amount of models that couldn't run through quantization, and around like 20% that will lose part of its accuracy, and it may be a pretty significant part. Is it critical? No. Very often you can take another one neural network with similar functionality instead of your specific one. And it can be easily quantizable, it can achieve almost the same accuracy, and you just don't need all complex pipelines. So it's both Hailo strength and its weakness, because I prefer not to use quantization in situations where it's possible. But if I should use quantization, then Hailo is the best choice. Okay, the next important point is supported models. There is an official list of supported models. But I would like to point out, not all models from the list are fully workable. Some had problems with quantization, for example, like efficient net models, and some were not exported in the native version and required specific modification. Probably you need to use training Docker from Hailo, for example, and it's not very nice in my opinion, but it is what it is. I would also like to note that in recent years the number of supported models has increased, and that's important. Hailo doesn't stand still, it's developing platform, and there are a lot of really nice updates, like each time I download new Hailo RT or Hailo export tools, each time it's become better. More and more support and nicer to use. So in my opinion, it's like you can't rely on all models, but it's become better and better. Also, I need to note that transformers are supported, but not entirely. A few months ago, at least Whisper could not be launched. Some transformers are not exported, and some are too big for quick inference. On Hailo 10, partially this problem is solved, but you need to be extremely cautious with your transformer-based models, because it's possible that they will just not run Hailo. Okay, I want to give you a few advices about correct pipeline for working on Hailo. As I mentioned before, there are a lot of instabilities with different models. So you need to minimize your problems at the beginning. First, you need to choose like 3-4 models that are suitable for you, and those that are officially supported by Hailo, at least in the like list of supported models. After that, you take such models, trying to quantize them and export them to Hailo, and you need to verify that everything will go smooth, that quantization is stable for such models, and that you can easily run everything. After that, probably few of models, you will drop few of models because it will be too hard to work with them. After that, you train the remaining models on your data and check which one of them performs better. After that, you take this best model, export this model to Hailo with like maximum number of quantization algorithms, and you check in how good is your accuracy. If your accuracy is good, still good, and there is no significant drop, you just take in this model in the production. But in case if this model is not working, you like taking the next model that you already verified and trained, and you trying to export this model. It's better to take models with different architecture, like if you are taking efficient net model, probably you need to take some ResNext or something based or on ResNet model. So, and this is how you work with Hailo. You need to constantly keep it in mind that your platform will limit your production, and it should also limit your research as well. The last thing I want to mention that it's a really good support from Hailo. The guys respond super quickly and efficiently. It's simply divine compared to support from Intel, Nvidia, or Qualcomm, or Rockchip. So in my opinion, like, Hailo is one of the best support on the market, but I never tested like modern boards like Accelera, Suno Ai, and stuff like this. So probably with them you can get better support, but specifically from like big grand companies, Hailo has one of the best support. So thank you for your attention. I hope this video helped you decide whether to work with Hailo or not. If you want to know more about Hailo, watch another video on my channel about it. And my entire channel is available for you to learn more about different edge boards for computer vision and stuff like this. So subscribe. Thank you for watching. Bye.